It is noon. All right, so we're going to learn about exponential and logarithmic. And the exponential is not, let's just say it's not the typical exponential kind of stuff. It's a little bit easier, I think. So we're going to learn how to solve exponential and logarithmic equations. And
I'm gonna grab a piece of paper.
okay, I will go slow. We're going to learn to do this. Okay, we're going to learn to write and evaluate the expressions. We're not going to graph. Not going to graph. Jamie, are you back from California? No, you're still in California? Okay. Well, I'm glad you came. All right. So we're going to talk about logarithms and a little bit about exponentials. So the exponents used by the Richter scale are called logarithms. So whenever you hear about an earthquake, or even I think tsunamis, they even use the Richter scale. As far as how big they are, they say they were 2.4 or something, but that's a logarithmic scale. The logarithm is to the base of b of a power, of a positive number is defined as following. So when you see something that looks like this part over here is your exponential, all right? And then to write this would be an exponential equation. So to write it as a logarithmic equation, we would write it like this, okay? Does that make sense? Okay. So I already did the first one here. So we're going to write some problems. These are exponential equations, all right? And we're going to write them as logs. So again, the first one we already did. This part down here, even in an exponential, we're looking at just the 5, is called the base, all right? In order to translate that to logs, this part down here is also called the base. So anytime you see this number, whatever's being raised to a power, that's going to be the base. Okay? All right, so I did the first one. So second one, you guys, how would I write this? And since you guys are here, you can tell me.
Would it be 6?
I'll do the hard part. Okay, now what?
Maybe 6.
Remember, this is the base.
Oh, okay, so 3.
3 goes down there.
7 to 9 goes up there.
That's right.
Equals 6. Yeah.
Equals 6. Good. So that's how I would write that. What about this one? I'll do the hard part. What 10? Jamie?
Oh, I think she.
Oh, that's log. Yeah, thank you. Yeah, thank you, Michaela. That is true. That is supposed to say log, L-O-G. All right, so for this one right here, what is my base?
The half.
The 1/2.
Yeah.
Okay. So log base of 1/2, log of 1/2, sorry.
And then the 1/8, and then equals 3.
3. Okay. And if we were to do this to the 3rd power, that would mean 1 to the 3rd power divided by 2 to the 3rd power. And 2 times 2 is 4 times another 2 is 8. So that's how we get that number. Does that make sense?
Mm-hmm.
Okay, last one.
10,
Log base 10,
and then 0? No, 1
1
equals 0.
is equal to 0. So what this part is telling us is that any number raised to the 0 power is going to be 1, right? For the most part, when you write logs, this, if you don't see a number down there, or if you just see log of, I don't know, log of 10, then that means, since there's nothing down here at the base, that is 10. 10 is called a common log. So if you don't see anything there, it means 10. All right? Okay. So what we want to do here is we want to try to solve this. Okay? So what did you remember from a couple slides ago? This is our base, right? So it's going to be 8 raised to the x power is equal to 16. Okay, so in order to do this, this really just jumps right in, doesn't it? We need to get the same base on both sides. Okay, so what is the same base? What number can I use for both of these? A base. Stephanie?
Wasn't it?
No.
Isn't that the common?
That's the common log, so that would be like down here. This one, it's kind of hard.
Jamie said 2.
Yes, thank you, thank you. I always forget to look down there. That is right, yay, Jamie. Okay, so we can take 2, and if I cube it, right? What about over here? 16, if I have 2 as a base, what do I raise it to? Let's think about 8, right? 2 times 2 is 4, times 2 is 8, times 1 more 2, 16, so that's 4, right, Jamie? Okay. All right, so now over here, we've got to go back a little bit because I think we've already done this. If we have a power raised to a power, what do I do with those? Do I add them? Do I multiply them? Do I subtract them, or do I divide them?
Divide.
I multiply.
Oh,
You divide whenever, actually, if I had 2 to the 3rd divided by 2 to the 4th, then I would divide those, so I would subtract them. Okay. So now, what do you think I do? I want to solve for x. I want to find out what x is. What can I do here? So simple. And I'm asking, what do you think? Tell me what you think, seriously. I want to solve for x.
If you want to solve for x. Jamie said, what's the question?
The question is, I want to solve for x. Thank you. So what do I do to try to solve for x? I have the same bases here, so that means I want the exponents to be equal, so I set them.
What was I saying?
I set them equal. And yeah, I'm going to kind of divide, right? Because I want to solve for x. Okay, so does that make sense?
A little bit.
Okay. So this is the way that you're going to do this. I can't put in a clean sheet, can I? Nope. So I'm going to write it up here as best I can. First step, you are going to set it up as an exponential equation. Second step, you're going to find the same bases if it's possible. Sometimes you just have to put these into a calculator. And then once you do that, you're going to set the exponents equal to each other. Okay, so here we did step 1, here we did step 2, and then here we did step 3. All right? Okay. So, all right, won't do it for me. That's lovely. So now I'm going to try to erase. Okay, there we go. Erase. Okay, fine, don't erase. What about this one? What do you guys think? How would I, just tell me how to set it up. So I want to do step 1. Go ahead, Michaela.
So you would still set it up like the regular one, it would just be x. So like 9x equals 27?
Yes, exactly. Good. I'm going to write over here. Okay. So what's the same base? What base can I use for 9 and 27?
What goes into? So do we have to do like what goes into both of them?
Yeah, what divides evenly into both? Like if I had a 9, right? And obviously I do. What can I do? What divides into 9? 9.
3.
3. Does 3 divide into 27?
Yes.
Yes. How many times?
9.
9 times. So how many 3's does that make? This is kind of weird. 3 and then 9, right? How many 3's are in 9?
4. No. How many 3's are in 9? 2.
2. So altogether you have 3 9's. Does that make sense? 3 times 3 is 9, times 3 is 27. So it's going to be 3 cubed. All right, so what did we do over here with my exponents?
So don't you make like the exponents equal to each other? So like
Right.
2x equals
Yeah, good.
3 to the third.
2x, that's a big X, is not 3 to the third, it's just equal to 3.
Oh.
You just set the exponents equal to each other.
Oh, okay.
So x is 3 divided by 2. And you can just leave it like that. Okay. All right, so I'm going to leave this problem and I'll write it out for those of you that are not here in attendance. See how lucky you guys are to be here? Okay, so we're going to evaluate. Last one. 10, a log base 10 of 100. Quick, how fast can we do this?
Okay, so it'd be 10x equals 100.
Yep.
And then what goes into 10? Well, 10.
10, right?
Yeah.
Good. So 10x is equal to how many times?
10.
10 times 10, right? So 2.
And then make the exponents equal. So 10.
That's it.
Oh.
That one we didn't have to do anything else. Good.
Wow.
Excellent. Okay, so quite honestly, that's pretty much what you're going to be doing this time. The thing that we did on both of those, that's what you're doing. That's it. That's the first one is your common log. That's your practice 1. Practice 2 is changing it from logs to exponentials and solving the exponential. Easy stuff. So let's look at this. This says a common logarithm is a logarithm that uses base 10. All right, so you can write it like this, or you can just write it log with no 10 down here. You don't have to write the 10. Scientists use common log to measure acidity. So I don't know if you guys are in biology, but in biology you work with pHs. And so where the way that you get the pH is they use this log of hydrogen. Okay, you guys know what hydrogen is.
Yeah.
And if have you done pHs yet? Okay, so you will. Oops. All right, so the pH of lemon juice is 2.3, while the pH of milk is 6.6. We want to find the concentration of hydrogen ions in each substance, and which substance is more acidic. Which substance is more acidic? You guys know this better than I do. Milk or lemon juice?
Would it be milk? The number's higher.
But what is that neutral number? Do you guys know what that neutral number is? pH of 7. That's neutral.
Okay.
So which of these numbers is closer to 7?
6.6.
6.6. So this is more acidic than this. All right? And I think this is just a real world connection. And you guys, again, who, if you're in biology, you know how to do this kind of stuff. Okay. All right. We're going to look at some exponential equations here. And it's the stuff that we just did, okay? So I think there's just a couple problems. So, but it's, okay, it's what we just did, but a little bit more. Does that make sense? Okay, good. So the idea here is to get the exponent part by itself. And then we're going to take the log of both sides and we're going to use the power property to solve for x. So let's see if we can do this. So if I were solving this equation, what would I do first?
Would you do 2 times 3x?
You can't.
So would you subtract the 1 from both sides?
Yes, excellent. Subtract the 1 from both sides.
Which leaves you with 2x.
2.
2 times 3x equals 8.
Okay, what do I do next? Good, Jamie. Move that.
Minus. She said minus 2.
Not minus. These are being
Divide.
multiplied. Yeah, so we're going to divide. Good.
And that leaves you with 3x equals 8 divided by 2.
Which is?
4.
4. Now, this is where you would need to use a calculator. Okay?
Would it be 3 divided by 4? I mean 4 divided by 3?
No. Okay. And that's good guesses, really. Seriously, good guesses. But this is where you would actually use your calculator. And what you would do in the calculator, there is a log button. Okay? So we're going to take log of 4, and I don't have my calculator here, so I don't know what that is. And this exponent part, you're going to put down in front. Okay, so pay attention. This is how you would solve these. Again, you have this log button in your calculator. It's log. Now, this is what I've gotten so far. So what am I going to do next to solve for x? These things are being multiplied. I want to get x by itself.
So we divide?
Divide. And again, in your calculator, you have this log button, and I think Desmos has it too. So you would find this answer and then divide it by this answer, and that would be your value of x. Does that make sense? Mine says 0.47. Yeah, then that's what it is. X is 0.477. You don't need to use all those numbers. Okay? Does that make sense? And you need to use a calculator unless you know what log base 10 of 3 is. And I do not. Okay, so this is important. There's, I think, 1, maybe 2, and they're just, you know, if you get it and everything else is really easy, try it. Okay? If you don't get it, don't worry about it. We can talk about it. All right, guys, that's it. Questions?
Nope.
Remember, if you're here, go to the webinar thingy and say attended, and you do not have to answer this lovely question.
Which webinar is this for?
Week 8. This is week 8. And I will tell you right now, that's okay. You can type in attended, Israel. For week 9, it's going to be another catch-up week. Okay, so just so you know. Alrighty, guys, that is that. No questions. Have a lovely week.